then we have addition will be used, but let me stretch this out just a second here. That may also require multiplication. So what we hope for in a problem like this, our goal is to be able to say, we can add the equations, and force one of the variable terms to cancel. And that's why multiplication may be necessary, because when I look at this particular problem, I say, if I try to add these two equations together as they are right now, what happens when I add 3x and 2x? 5x. What happens when I add a positive y and a negative 3y?
Negative 2y.
Did I successfully get rid of one of the variables? So they're not ready to add together as they appear right now, which means I've got to do some manipulation, some changing. Okay, so the ultimate goal is to set up a situation where the variables are going to have the same coefficients but differ in signs, or in other words, opposite coefficients. So essentially what's happening over here is we need to arrange the system. Okay, so we may need to arrange the system so that one set of terms has opposite coefficients. If we wanted to attack the x terms in the problem and wanted to force that to be the variable that would be eliminated, we would have to arrange it so that those two coefficients would turn into something that's going to be equivalent to one another, which is the sign difference, which means that we would need the least common multiple of those. That means I'd have to multiply both equations by something. That may be possible, it may be necessary, but if we can get by with only multiplying one equation by something, that would be easier. In this case, the best idea here is to target the y terms, because I'm only going to have to multiply one equation instead of having to multiply both equations. Now, if I'm trying to target these to get opposite coefficients in here, I know I already have an understood 1 in here, so I'm going to need to multiply one equation by something that would get me my desired results. Makes it the top equation, right? So what are we going to multiply by? 3. So we multiply a top equation by 3. Three is going to be multiplied all the way across the top equation, which is 3x plus y equals 10. Now that's a transformation, a change step. When we do that multiplication problem, remember that it's all the way across the equation, everything. So we're going to get a 9x, we're going to get a plus 3y, and we're going to get a 30. Common mistake, people forget to multiply the constant term as well. You're enlarging everything in that top equation by a factor of 3. Bottom equation needs no change. if we target the y variables for elimination. So it can come down strictly as it was written, 2x minus 3y equals 8. And now, these can be added. And when we add them, we're going to get rid of the variable that we were targeting in the problem, right? So when we add these two equations together, we still come up with this 11x, but don't these two variables here drop out of the problem? And that's exactly what we wanted, was to get rid of those two variables. So 11x now is going to be equal to 38, and isn't that very similar to, in fact, not exactly the same as what we had in the other problem? So it's not going to change the amount of work you have to do, it's just going to change the approach that you take. And that's like saying I can drive from here to New Orleans by going through Slidell. Certainly you can, but the scenery is going to look a lot different than if you drive from here to Laplace and then go across the Spillway. You still get the same place, but the amount of work you get, what you see along the way, what you have to do along the way might be different in the problem. So you need to make intelligent decisions. But the good news is there's only one problem you have to make that intelligent decision on, and it's the very first one, because after the next, in 5 minutes, we'll be looking at a calculator approach to the problem that will make doing things by hand unnecessary. But it's a new tool, okay? So we're going to divide both sides by 11 still. That's still going to give us that 38 over 11. We're still going to have to be able to go back and find our value of y. So we'd probably pick one of the two equations that we had to begin with. And again, it wouldn't make a difference if it was the 3x plus y equals 10 or the 2x minus 3y equals 8. But most people will pick the one that has a nicer set of coefficients. And we need to find its secondary value in that problem. So if we come back and we use 3x plus y is equal to 10, now we're saying 3 times the x value plus y equals 10. And I know that I'm going to have to do this multiplication problem, but I also know that eventually that's going to come over here, and we're going to subtract that from both sides to be able to get the like terms together. Well, if that's the case, then why not just save it all for one step?